I get comments on my videos that show me that a lot of people really do not understand the difference between laptop PC specs and desktop PC specs. I see this on my benchmarking videos and my system requirements videos, where sometimes people will be like, I have the same GPU, but I'm getting completely different performance. And if you actually ask them about it, they have the they have the laptop version of the part. I'm testing the desktop version of the part, and these are not the same thing. They may be dressed up the same, they have the same name, but they are not at all the same components. So I saw this post on Reddit here, is the gap really that big? Kind of asking the same question, getting at the idea that the laptop components and the desktop components really don't match up. Now, the important thing is that pretty much any modern gaming PC, laptop, or desktop is going to play Slay the Spire 2 just fine, and that's all I've been doing lately. So I figured I'd take a break from Slay the Spire 2 to make this video, though, so I keep my channel going. I've also noticed that asking Google AI also gets you really bad answers. And I've been noticing this a bunch, where I see people relying on Google AI to give them answers about PC components, and it's usually wrong. I've actually been trying out asking it some questions about the kind of things that I make content about, and it is terrible. Like, if you ask it for a PC build, you'll get stuff from like a generation ago, because it's reading documents from, the years, and it's not really interpreting it in current context. It's not good at current pricing. I'll even ask it just for specs on a current GPU, and it's often just wrong. So this is a place where I get a lot of hallucinations. So, Google AI is saying that NVIDIA laptop GPUs are generally 1 to 2 tiers lower in performance than their desktop counterparts with the same model number due to power and cooling limitations. Now, it's true that some of the big differences are power and cooling limitations, but also they literally just have different amounts of CUDA cores. Like, it's actually just a physically different part. There's differences in VRAM, but the power and cooling limitations are also pretty big as well. Also, my issue with this is 1 to 2 tiers. Well, 1 to 2 tiers can be pretty different, whether it's 1 or it's 2, but also sometimes it's less than a tier of difference. Sometimes they're fairly close. So I did some benchmarking. I don't have a bunch of laptop parts. I do have a mini PC that has a mobile RTX 5070 in it, and this one runs at pretty much the full power allotment, or at least pretty close to it. But other 5070s could actually run at lower power constraints. So that's another problem with this kind of thing, is that even if you're talking about a mobile 5070 against a mobile 5070, because even within the laptops, they can have different power and thermal limits, they don't always perform the same. So really, you kind of need to look at the specific laptop that you're interested in and what kind of thermal power constraints are placed on the GPU. But anyway, here's my mobile 5070 on the left, benchmarked at the same settings as my desktop 5070 on the right. And this is Clair Obscur Expedition 33 at 1080p ultra settings. And here I'm seeing 47 FPS on the laptop 5070 versus 68 FPS on the desktop 5070. That is a 45% performance advantage for the desktop 5070. That's a huge difference. This is like mid 40s versus almost 70 FPS. And again, one of the big differences is the power draw, where the 5070 on the left is drawing a little over 100 watts at times, whereas the desktop 5070 is often just a little bit under 200 watts. Pretty big difference, but there's also some other differences. Now, I also checked out, well, okay, if you use DLSS quality on 1080p Ultra, then the laptop 5070 is able to get you 63 FPS, but the desktop GPU at those same settings is getting you 90 FPS. That's a 43% advantage for the desktop part. Also notice that the laptop 5070 using DLSS quality is still slower than the native resolution on the desktop 5070. And these GPUs, in addition to having different numbers of CUDA cores, different power constraints, they also have different VRAM capacity. So I'm going to skip ahead in my benchmarks here a little bit. I did benchmark medium settings, 1080p. It was 70 FPS mobile, 103 FPS on the desktop. That's a 47% advantage for desktop. I also tried out medium settings with DLSS quality. The mobile 5070 is getting 87 FPS. The desktop 5070 is getting 125. So again, 44%. So we're seeing that kind of mid 40% advantage for the desktop part. Now let's go ahead and jump to something interesting. So I want to pause here real quick because this is where we see the difference in VRAM come into play. This is 1440p Ultra settings, and at native resolution, the laptop 5070 is going to have a lot more frame time spikes and bad 1% lows because it has 8 gigabytes of VRAM, whereas the desktop 5070 has 12. So we can see all these spikes here that are much smoother here. The 1% lows here are at 2, the 1% lows here at 38 in the same scene. Now, eventually, this game kind of, after initially loading in, things smooth out a little bit, but overall performance still seems low. And the average frame rate is a 58% advantage here for the desktop 5070. But again, that's accentuated because of the VRAM difference rather than a raw performance difference. And again, you can adjust settings down to be within your 8 gigabyte VRAM buffer, but that's something you have to be less concerned about on the desktop part. So that's some pretty major differences. Now, if I do go ahead and use DLSS balanced at 1440p Ultra, now the laptop 5070 is hitting 54 FPS, and I'm not seeing the crazy spiky frame time graph. The 1% lows are under control. And the desktop 5070 is back to a about mid 40% lead. So in this case, 46% lead at 79 FPS. So still a healthy lead, but not as much as we saw when the VRAM was spilling over and causing more concerns here. Now, I benchmarked some other settings, 1440p medium on the laptop 5070, it's hitting 50 FPS. The desktop 5070 is 52% faster at 76. 1440p medium with DLSS balanced. The 5070 laptop is hitting 76 FPS, so you can definitely still enjoy this game on a laptop 5070. The desktop 5070 at the same settings, I was hitting 111. That's a 46% advantage. I also checked out some other games. If you're more into like competitive games, here's Marvel Rivals 1080p medium. The laptop 5070 is perfectly respectable at 111 FPS, but the desktop 5070 is hitting 160 FPS, which is a 44% advantage. Again, we're noticeably getting that kind of mid-40s advantage unless VRAM kind of comes into play here. 1080p medium DLSS quality, the laptop 5070 is hitting 138 FPS, the desktop's at 204, it's a 48% advantage. 1440p at medium settings, native TAA. The laptop 5070 is hitting 77 FPS, desktop's at 112, it's a 45% advantage, and 1440p medium DLSS balanced is 119 FPS for the 5070 mobile and 166 FPS for the 5070 desktop. It's a 39% advantage for the desktop card. I also took a look at Cyberpunk with RT Overdrive. At even 1080p resolution, you'd need to use DLSS in order to get reasonable frame rates, but 1080p DLSS quality is playable on the laptop 5070, but it's not great. It's hitting 49 FPS average, and the frame time graph is pretty spiky because these settings use more than 8 gigabytes of VRAM. Whereas the desktop 5070, with its additional performance and its additional VRAM, is hitting 75 frames per second. That's a 53% advantage, and also it's not using any frame gen here. So mid 70 FPS range, kick on 2x frame gen. Now you're in a single player game in a pretty good situation. I also looked at not using path tracing. What if you just use 1080p medium? Well, then the laptop 5070 can hit 139 FPS at 1080p medium native TAA, whereas the desktop 5070 at those same settings is hitting 211 frames per second. That's a 52% performance advantage. But again, the laptop GPU is completely fine at reasonable settings. I also looked at 1440p. This is RT Overdrive DLSS balanced this time, and the desktop 5070 is able to hit 59 FPS average in the benchmark run. So, in a single player game, hit on 2x frame gen and you've got a reasonable experience. Whereas the laptop 5070 has a terrible looking frame time graph and is only hitting a 37 FPS average. So completely different experiences due to both the raw power and the VRAM difference on the two cards. Now, if we look at 1440p but just medium preset native TAA, well then the laptop GPU is fine at 94 FPS, and the desktop GPU is hitting 139, which is a 48% advantage. And I think that's all the benchmarks that I ran here. I guess I looked at medium settings, DLSS balanced at 1440p, 134 FPS on the 5070 mobile. 196 FPS on the 5070 desktop. It's a 46% advantage for the desktop part. But again, that's all the benchmarks that I ran here. So the problem with this is, so if you want a larger answer to the question of, is the gap really that big between these parts? Well, I mean, the answer looking at 5070s is clearly there's a pretty large advantage. There's a VRAM difference. There's a almost 50% just raw performance advantage, huge difference in the amount of power that's being used. Now, I did research to see if I could find anything more useful than this AI Google answer as far as somebody who's actually done a really good job benchmarking all of the laptop GPUs and all of the desktop GPUs in the same games. Again, when we look at that, though, you're going to need to keep in mind that not every laptop with the same GPU in it has the same performance because of the thermal differences where they can set a different power target. So there can be pretty wide variance. With that in mind, though, I did find at Hardware, it's Canucks, right? I'm not Canadian. It's not Canucks, it's Canucks. I think I got it right. Anyway, but they had, at least in my searching, the best video I could find with recent results on 50 series GPUs. I'm just going to show their results in Hogwarts Legacy because I don't want to give you a reason not to click on their full video. I'll link them in the video description. They have a bunch of games at 1440p. They have a bunch of games at 4K, at least some at 4K, I believe. They also have some creator workloads as well. So there's a whole bunch of good stuff here. But if we look at just one game as an example, we can also see why, again, while the AI is not completely wrong, well, it's just 1 to 2 tiers lower, that's not particularly useful. You really need to look at the specific parts. So, for example, we can see that the laptop 5050 and the desktop 5050 are virtually the same performance. So in that case, it's completely wrong to think that there's a major difference between the laptop GPU and the desktop GPU. 5050s, they're about the same. The reason is that part runs at low enough power that they don't need to seriously throttle the laptop version, and it's already pretty significantly cut down. So your thermal targets and your actual silicon quantity, in CUDA core count, is about the same between 5050 desktop and laptop. And I believe the laptop version actually gets GDDR7, whereas the desktop version gets GDDR6, which actually means that in some ways the laptop version's better, and I'm wondering if that has something to do with their 1% lows actually being better on their laptop 5050 here. It's actually a slightly better part on the laptop. Whereas if we look at the 5060 laptop versus the desktop, it's just a minor difference, but the desktop version is better. But I wouldn't class it as a whole performance tier or two down. It's certainly the case that the 5060 laptop is noticeably faster than the 5050 desktop. So it's not even close to a full performance tier down. What's the case, at least with these 50 series parts, is that the higher you go up the stack, the more power consumption the desktop part uses, and so the laptop part has to fall off. Also, they tend to just get you a more cut down part where you have less VRAM than the desktop component and fewer CUDA cores. So notice again that while the 5050 and 5060s all have 8 gigabytes, regardless of whether it's the desktop or laptop parts, and also your CUDA core counts are pretty similar. So everything's pretty similar, even if the parts aren't exactly identical spec. Notice in this video, we were looking at the 5070 laptop against the 5070 desktop. Completely different part of the charts here, right? Also, 5070, 12 gigabyte on the desktop, 5070 laptop's an 8 gigabyte part, it has lower power, it has fewer CUDA cores. Notice that the 5070 laptop is slower, actually pretty noticeably so, than the 5060 Ti desktop part. Now that's a 16 gigabyte part, so that's part of the difference. They didn't benchmark the 8 gigabyte 5060 Ti here, so that's factoring into any game that goes over 8 gigabytes of VRAM in these benchmarks. But the closest desktop equivalent to a 5070 laptop is a 5060 Ti, where I guess we could call that about the one tier down if you consider Ti, a tier, if that makes sense. So that's one way of looking at that. Now, the 5070 Ti laptop is a little bit better than a 5060 Ti desktop, but it is slower than a 5070 desktop. So the 5070 Ti laptop is noticeably worse than a 5070 desktop. And then even a 5080 laptop part here is noticeably slower than the desktop 5070, at least in this one game. Again, I'm just showing their Hogwarts Legacy result. You can look at more wider variety of games as you check the source here in the video description. Now, we have the 5090 laptop. In their testing here, at least in this game, is running slower than the 5070 desktop part. So keep that in mind if you're spending thousands of dollars on a 5090 laptop. It is not even remotely similar to the desktop 5090 performance. Not even close. Now, notice here that the 5070 Ti desktop is 5080 desktop and 5090 desktop are just off the charts. The laptop GPUs kind of top out at about desktop 5070 levels of performance. Again, that's in this one game. You might find certain games where the 5090 laptop does better. Also, it does have 24 gigabytes of VRAM compared to the desktop 5070 at 12. So if you're in a situation that goes over 12 gigabytes of VRAM, the 5090 laptop and 5080 laptop have some advantages there, and the 5070 Ti laptop at least matches it at 12. But again, notice that the desktop 5090 has 32 gigabytes, which for gaming is usually pretty much overkill, but if you're using it for like AI applications or other productivity tasks, 24 versus 32 can actually change like the model you can run or how much, of your video you can fit into memory if you're doing video editing and that kind of thing. So hopefully this video gives you some idea on what's going on here when we compare desktop parts to laptop parts. They're essentially completely different things. And that kind of brings up a little bit of a side note here where, they're putting laptop after these part names in the chart. I'm putting laptop in the chart name, in my testing. I'm saying mobile, or 5070M versus 5070D for desktop. I think it's pretty important to note that NVIDIA doesn't do that. They used to. They used to put an M after their laptop GPU names to indicate it was the mobile part. They don't do that anymore, which I think is leading to more of the confusion when people are like, 5070, I have a 5070. Yeah, but it's the laptop version, which is just an entirely different thing. So I really think that it's deceptive marketing not to at least put an M at the end of those parts. Now, I understand you guys might think, well, obviously it's the mobile part because it's in a mobile computer, like a laptop. But that is not obvious to the average consumer who might have heard or seen benchmarks about a 5070. You look up 5070 benchmarks when you're researching your part, it might not even occur to you that there's a different GPU called a 5070 that has completely different performance, but has exactly the same name. And it's going to be way easier to find benchmarks for the desktop 5070, and they usually don't specify that they're benchmarking the desktop 5070. They just benchmark the 5070. It's kind of up to you as the laptop buyer to understand it's a completely different part, which nobody in any of the marketing or specs sheet is making obvious to you. So that's kind of my little rant here at the end, is I think they need to at least stick an M at the end to indicate that it is a different part. Anyway, that's what I've got for you guys today. Hopefully you found the video useful and or interesting. Don't forget to check out these sources in the video description if you want to check out more of these thorough benchmarking than I'm able to do, because I just frankly don't have a bunch of laptops to benchmark. I do have the desktop parts, so I have lots of desktop GPU benchmarks on the channel. I don't have a lot of laptops, so all I was limited to is the mobile 5070 that I have access to. Hope all of you have an excellent day.